Yes, in the first video we learned first 3 inverse trigonometric functions. So next we are going to learn remaining 3 inverse trigonometric function. In the first one, inverse of secant x. Yes, as you observe in the first 3, these trigonometric function not bijective. So if it is not bijective, its inverse cannot be defined. So we restrict the domain and range of these trigonometric functions so that we can have bijective secant x, cosecant x and cot x. Yes, so restricted domain and range of secant x is 0 to pi except pi by 2. Why it is pi by 2 is removed? As you know, secant pi by 2 does not exist. Since it is not exist, it should be removed. Yes, so it is removed from the range 0 to pi. Yeah, with this restricted domain and range, we can define inverse of secant x very easily. How to define? First, interchange the domain and range. So with the interchange domain and range, the domain of secant x is minus infinity to minus 1 union 1 to infinity. So let me explain once what is this. See, if you take a real line means nothing but x-axis. Yes, this is the middle point, the 0. Here I'll mark 1, here I'll mark minus 1. Minus infinity to minus 1 implies you are going to take all the negative value up to minus 1, not including minus 1. You take all the negative values from minus infinity to minus 1, not including minus 1. As well as you are going to take all the positive value from 1 to infinity, these values. Again here 1 is not included. And definitely you are not going to include these values. These are not allowed. The reason is, with these values, this function secant x cannot be a bijective. If it is not bijective, its inverse cannot be defined. So you are going to take minus infinity to minus 1, 1 to infinity, except between minus 1 to plus 1. So with this domain and range, you can define inverse of secant x, inverse of secant x as follows. It's a function f from minus infinity to minus 1, 1 to infinity to 0 to pi, excluding pi by 2 that I explained here, defined by f inverse of x is equal to secant inverse of x. So it is secant inverse of x. Similarly, the next inverse trigonometric function, cosecant inverse of x. Again, same story. The domain and range should be restricted, otherwise it is not a bijective function. You cannot define its inverse. The restricted domain and range is as follows. So domain of cosecant inverse and secant inverse one and the same. That is minus infinity to minus 1 union 1 to infinity. Here 0 is excluded. What may be the reason? See this. What is the value of cosecant 0? Cosecant 0 is, yes, does not exist. So cosecant 0 does not exist, so you cannot include that 0 in the range. So remove that 0, remaining is same as that of sine inverse of x. So it's a function minus infinity to minus 1 union 1 to infinity to minus pi by 2 to plus pi by 2 excluding 0, defined by cosecant inverse of x. So these are the two inverse trigonometric function. It's almost same as that of sine inverse of x and cos inverse of x. Yes, the last one, it is related to tan x. So next function is inverse of cot x. Yeah, same problem you are going to face here also for cot x. It is not bijective. So with the restricted domain and codomain, you can define its inverse because you will get bijective cot function. Yes, what is the restricted domain and range? It is from minus infinity to infinity and 0 to pi. Now with this domain and codomain, a range, you can define inverse easily, and it's defined as f inverse of x is equal to cot inverse of x. Now here you can see in tan it is minus pi by 2 to plus pi by 2, but for cot it is not same, it is 0 to pi. The one reason is, what is the value of tan 0? Tan 0 is 0. So what is the value of cot 0? It is does not exist. So we have to remove that 0. If in this interval 0 belongs to that interval, here 0 does not belong to this interval, so we are going to take this range for cot inverse of x. The reason is cot 0 is not exist. So how to define inverse of cot x? It's a function from minus infinity to plus infinity to 0 to pi, defined as f inverse of x is equal to cot inverse of x. So these are the 6 inverse trigonometric functions. Here you should remember its domain and range. So let me explain more about this inverse trigonometric function by taking some standard values. This value you should remember. The first one, the first inverse trigonometric function, sine inverse of x. The first value is sine inverse of 0. Okay, you know that sine 0 is 0, right? Yes. Since sine 0 is 0, sine inverse, when you take sine this side, it becomes sine inverse of 0 equal to what you will get? Yeah, this value, that is 0. So remember, sine inverse of 0 is equal to 0. Sine 0 is also 0. Sine inverse of 0 is also equal to 0. Similarly, the second standard number you should remember, sine inverse of 1. For which angle, tell me, for which angle sine of that is equal to 1? Yes, your answer is right, which is pi by 2. Sine pi by 2 is 1. Therefore, sine inverse of 1, what you are going to do? You are going to take sine to this side. When you take sine to that side, it becomes sine inverse of 1. So this will be the answer to sine inverse of 1. So remember, sine inverse of 1 is equal to pi by 2. Reason is sine pi by 2 is equal to 1. Okay, the next standard value, sine inverse of half. Again tell me, for which angle sine will give half? Yes, answer is pi by is 6, that is 30 degree. Sine pi by 6 is equal to half. Therefore, sine inverse of half is equal to pi by 6. So you must remember these values. Sine inverse of 0 is 0. Sine inverse of 1 is equal to pi by 2. Sine inverse of half is equal to pi by 6. The next standard value, sine inverse of root 3 by 2. Again tell me, for which angle sine will give you the root 3 by 2? The angle is pi by 3, that is 60 degree. Since sine 60 degree is root 3 by 2, sine inverse of root 3 by 2 will be 60 degree or pi by 3. So remember, sine inverse of root 3 by 2 is equal to pi by 3. The last one, sine inverse of 1 by root 2. Yeah, now you definitely can answer, yes, it is nothing but 45 degree or pi by 4. How you can answer this? Because you know that sine 45 degree is equal to 1 by root 2. Therefore, sine inverse of 1 by root 2 is equal to pi by 4. So these 5 values you should remember. I'll repeat again. Sine inverse of 0 is equal to 0. Sine inverse of 1 is equal to pi by 2. Sine inverse of 1 by root 2 is equal to pi by 6. Sine inverse of root 3 by 2 is equal to pi by 3. Sine inverse of 1 by root 2 is equal to 1 by root 2. Similarly, you're going to now find the values of these standard numbers for cos inverse. Yes, the first one, cos inverse of 0. For which value of cos it gives 0? Yes, answer is pi by 2. Therefore, cos inverse of 0 is equal to pi by 2. Remember, this is an important value, so you should remember. Yes, next one, cos inverse of cos of which angle gives root 3 by 2? It is 30 degree. So cos inverse of root 3 by 2 is equal to 30 degree. Remember the next cos inverse standard value, which is cos inverse of root 3 by 2 is equal to pi by 6. Now for which angle cos gives 1? Yes, cos 0 is 1. Since cos 0 is 1, cos inverse of 1 is equal to 0. Last one, cos inverse of half. Yes, for which angle cos inverse gives half? It gives half for pi by 3, that is 60 degree. So cos inverse of 1 by 2 is equal to pi by 3, that is 60 degree. The last one, cos inverse of 1 by root 2. So cos of pi by 4 is equal to 1 by root 2. Therefore, cos inverse of 1 by root 2 is equal to pi by 4. So these are the next 5 values you should remember. Cos inverse of 0 is equal to pi by 2. Cos inverse of root 3 by 2 is equal to pi by 6. Cos inverse of 1 is equal to 0. Cos inverse of 1 by 2 is equal to pi by 3. Cos inverse of 1 by root 2 is equal to pi by 4. Thank you.